Hey everybody, welcome to a video on normal distribution. We're first going to take a look at percentile rank and then we'll get right into the normal distribution. So if you look here, we've got a histogram with height in feet and the frequency. We're talking about trees here. The 65-foot tree is going to fall into this bin here because remember that if it's on the edge here, it always goes to the bin to the right. So we have 3 data values that are below where we are, and we have 31 total data values. So what we're going to do is we're going to take 3 over 31, and that gives us 0.097. So it's in the 0.97 percentile. Okay, in which interval is the 60th percentile? So we're going to take our 31 pieces of data times 0.6, which means there are going to be about 18.6 values or 19 values below our data value that we're looking for. So the 19th value, this is 3, that's 6, that's 14. So the 19th value is going to be somewhere in this 75 to 79.99 bin. So this interval right here, 75 to 79, is where that answer is going to be. Alright, a little bit of a funny here for you. This cartoon says, "I assure you, madam, Prestige Academy accepts no students below the first percentile." So this guy's really trying to talk to this woman about how great his school is, but he either doesn't know what he's talking about or he really does know what he's talking about and is trying to make it sound good. So anyway, I find that one amusing. Normal distribution curves. Today you're going to be able to sketch the normal distribution curve with the mean and the standard deviations in the proper positions. Use the normal curve to find percentile rankings and intervals for percentages of the distribution. And understand this 68, 95, 99.7 rule, how it works, and its relationship to standard deviation. So when are you ever going to use standard deviation? Well, I thought you'd never ask. You may have seen a commercial a year or two ago about this website called TrueCar, and it actually uses standard deviation and normal curves here to show the average price that somebody paid, what the manufacturer's suggested retail price is, what the factory invoice is, and how many people paid differing prices in there. And obviously when you buy a car you want to be down here because you want to be paying the lowest price. But it's good to know what everybody else is paying. So there is your real-world application of normal distribution. All right, so this next screen has a lot of stuff on it. And I'm going to talk you through each little part, and then we're going to do some examples, and then you're going to have some practice. So taking a look here, normal distribution curve. It's symmetric, it's single-peaked, and it's bell-shaped. And all normal distributions have the same overall shape. They start down, they come up, and then they come back down. Some of them are narrower, some of them are wider. A particular normal distribution is described by its mean, with this symbol here, I believe that's mu, and standard deviation, and I think that's lowercase sigma. Mu, or the mean, is located at the center, just like the median, the 50th percentile. Sigma indicates the spread of a normal curve, or standard deviation, spread of a normal curve, and it's a natural measure of spread for normal distributions. So this is what it's going to look like when we're done, and this is a little bit messy, but I will take a couple minutes to show you how this is going to work for us. Okay, so this one's a little bit cleaner. This is our mean right here. Okay, this is our standard deviation. This area in here is one standard deviation away from the mean, and this space underneath this normal curve accounts for 68% of our data. So 68% of the data is in there. That means 34% is here and 34% is here. So if this is 50th percentile and I add 34%, that's how I get this 84 here. And if I take my 50th percentile and I subtract off 34%, that's how I get my 16%. Okay? Again, here's our median. We just talked about one standard deviation away from the mean. Now we're going to look at 2 standard deviations away from the mean. So this was our 34%. This is a little bit more. Okay. So this is going to be 13.5% in here. And this is going to be another 13.5%. Because if you take 95% minus 68%, you get 27, and you divide 27 by 2, so 13.5 is here, and 13.5 is here. We're going to 3 standard deviations away from the mean now. Okay, so here's 68%. Here is your 95%. So 95% of your data is within 2 standard deviations of the mean. And if you recall from a previous video, we said an outlier was anything that was more than 2 standard deviations away from the mean. So this area down here would be considered an outlier, as is this area here. Now this pink line represents 3 standard deviations away from the mean, which is 99.7% of the data. So when you look at 99.7% in relation to 100, that's 0.3% of the data is left, which means that there's 0.15% here, and this is 0.15% away from 100 here. All right, so what percent's in each part? Let's see if we can remember. These are our 34%, because that's 68% of the data. The purple area here, this was 95% of our data. So in each of these little compartments here, that's 13.5 and 13.5. This was 99.7% of the data. So in here was 2.35% on each end. And then finally, if you look here, this is 50%. You add your 34%, that's how you get 84. You add a 13.5%, that's how you get your 97.5. Add your 2.3%, that's how you get your 99.85. Similarly, but subtracting, if this is 50% or 50% and you subtract off 34%, you're at 16%. If you subtract off 13.5, you're at 2.5. If you subtract off your 2.35, you're at 0.15. So that's where all of those numbers come from. And there's a lot on there, but the more we work with this, the better we'll do on it. All right, so here's an example. Young women ages 18 to 24 have an approximately normal distribution, with the mean height being 64 inches and a standard deviation being 3 inches. Sketch a normal curve that shows the mean and the plus or minus 3 standard deviations correctly located. So what we're going to do here is we're going to take a look, and right here, where did I put it? 64, that's your mean height, okay? Standard deviation is 3 inches. That means I would add 3 inches to 64, and I would subtract off 3 inches from 64. So that's 1 standard deviation away from the mean. I'm going to add another 3 inches. That's how I get to 70. I'm going to subtract another 3 inches. That's how I get to 58. Back over here, add another 3. I'm going to be at 73. Subtract another 3. I'm going to be at 55. So 68% of our data fall between what numbers? Well, this is 68% in here. So 68% of our data falls between 61 and 67 inches. 95% falls between what numbers? Well, 95% is this here. So we should expect that to be 58 to 70 inches. And 99.7 fall between what numbers? That's going to be 55 to 73. So 2 standard deviations away from the mean. Remember, anything bigger than that is our outlier, bigger or smaller. So this is 2 standard deviations away right there. So anything smaller than 58 would be an outlier, or anything larger than 70 would be an outlier. All right, take a moment, pause the video, try and answer these questions here. What percentage of students fall below 67 inches? So here's 67. Remember, this is 50th percentile. If we add our 34% on there, that should be 84%. What percent are above 61 inches? Similarly, this is 50%, and you add on your 34%. That's going to be your 84%. What percent of the data fall between 58 and 67? So from here all the way to there. Well, this is your 34% and 34% and 13.5. Or you can go the other way. 100 minus 2.5 minus 16 gives you your 81.5. If a young woman is 70 inches tall, what percentile would she be at? How many percent of the people are below her? That should be 97.5% of the people are below her, because there's only 2.5% of the people above her. Or you can count all the way to here. You can count up to your 50 plus your 34 plus your 13 and a half. All right. That's it for today. Hopefully you're able to use what you learned to do some mastery work on normal distribution. Thanks for watching. Have a good rest of your day.